Hi everyone, I'm Eric. Today our group will be talking about the technology that is changing the way people see the world, and that is mobile augmented reality. Before we go any further into the main topic, I would like to introduce mobile computing first. Mobile computing is one of the key concepts in building mobile augmented reality. It has been defined as a technology that enables people to access network services at any place, anytime, and anywhere. Mobile computing has three main characteristics that makes it so special. First, portability. Second, connectivity. And last is the interactivity. We might be unfamiliar with mobile computing, but I'm sure that we know a lot about mobile computing devices. Take a look at the phone next to you. That is one of the representation of mobile computing devices. To access software functionality and hardware of mobile devices, the primary way is through the mobile application. It is a type of software that runs its services on top of the mobile operating system. In fact, in the past decade, mobile computing has encountered some hurdles because of hardware and computing resources limitation. However, as the storage units, batteries, and processing chips are getting smaller and cheaper, the development of mobile computing has skyrocketed, and it has created a wave of technological innovation and provided great opportunities in the market. Developers starting to merge technology into mobile devices host. A representative example is augmented reality, which we called AR. Next, Simon will talk more on the relationship between AR and mobile computing. Also explore how the concept of mobile AR is formed.
Augmented reality means overlaying digital images onto the real world to enhance them with digital details. When people look through the mobile devices at the world around us, it makes us feel like enter the virtual world and interact with the virtual world. With AR technology, people can use TikTok effects to augment their looks. Girls can try different types of makeups. Children can catch their own Pokemon in the real world. Here's a quick glance of IKEA Place, which brings an amazing success in the industry. With AR technology, customer can place IKEA furniture into the house. People can even try different shades of Dulux paint on their walls.
In terms of AR technology, it transforms volume of data into images or animations that are overlaid on the real world. One of the significant challenges is to explore the unknown environments. Simultaneous localization and mapping is a technology for obtaining the 3D sculpture and sensor motion. This technology enables AR applications to recognize 3D objects and things, and to overlay digital interactive augmentations. One of the components in SLIM is sensing. It is a process of get physical properties, including precision, distance, and speed. The most common used sensors are light detection and ranging, radar, and camera. The high cost of sensor is one of the reasons that limited the AR applications. With the development of camera on mobile phone, mobile AR applications are now getting a lot of attention. The second component is mapping. In mapping, the information captured by the sensors is processed by the backend. Feature-based method is widely used, and these algorithms acquire images captured by sensor and search for certain features and key points, such as corners in these images. Then, data are used to correlate with landmarks to build a map.
There are mainly three limitations in today's mobile AR applications. The first is limited computational resources. Since most of the AR tasks are computing and data intensive, it requires lots of resources, such as CPU, to do the calculations. However, the resources are limited on mobile devices, so the computation accuracy is not as good as expected by users. Also, the rendering capabilities are also limited, which results in users could not see what they have expected in front of the screen. Therefore, user experience is degraded. The next limitation is latency. Some of the tasks will need to be offloaded to the cloud servers because they cannot be conducted on local devices. Transmission between local devices and the cloud server takes time, which results in high latency. The third limitation is the high power consumption. Since the computing and rendering tasks cost a huge amount of energy, the battery on the mobile devices needs to be strong and even keep charging when doing AR tasks.
Due to the limitations described above, we could offload part of the task to the remote cloud, allowing them to be computed in the cloud and returned to the application side. The process of edge computing could be divided into two parts. The first part is task offloading, which refers to whether the tasks need to be uploaded to the edge network for computation or computed locally. This part should calculate the energy consumption for both local and edge computing and conclude whether to perform task offloading or not. If offloading is not required, the local computation will be performed directly. Otherwise, it goes to the second part. Task migration in the edge network structure needs to be considered when the task chooses to be uploaded to the edge network for computation. Moreover, the path of the task from the server location where the task is offloaded back to mobile application is selected by performing the algorithm related to task migration. However, cloud offloading will present communication latency issue due to data transfer rates limitations and network latency issues. Therefore, minimum energy consumption and minimum latency are the main current research directions of edge computing.
This emerges a problem that the cloud offloading will cause a high latency because the data is transmitted in the network. Therefore, we cannot put every task on the cloud. An innovative method called Marvel can decrease the latency within 100 milliseconds, which is acceptable by end users. This method utilizes local resources and conducts most of the calculations locally. It only transmitted data to cloud server when calibrating calculated AR results. Therefore, it can reduce latency. Initially, it builds two kinds of databases. One is a three-dimensional point cloud database, along with all three-dimensional points. Then it shoots a 2D video and calculates 6 DOF positions between features. Then it maps two-dimensional features to three-dimensional. That's how these three-dimensional points are generated, and they will be stored in the cloud server. At the next stage, it filters data that is lower than the threshold to reduce the computation complexity. After computing 6 DOF positions for the object, it converts 3D real-world points to 2D locations on the digital screen.
Next, I will describe the rest of Marvel's system, including local visual tracking, image offloading, and celebration. In fact, while the mobile device is processing inertial information, he is also processing the visual data. The feature in their stage is processing camera data. The first, Marvel detects whether the image is sharp enough using the doorbell operator. Second, based on the information obtained from the second stage, checked this image whether contains difference. If yes, boom, the image performs optical flow estimation. The fourth stage focuses on the comparison of the results from the last two stages. If there is a large deviation between the position from the second stage and the estimate from the third stage, Marvel will offload the image to the server and request the server to measure the offset. Finally, the server will read localization and rank the images. The champion image will be sent back, and the mobile devices will use this data in the second stage for celebration.
According to the existing works and the researchers, we have conducted some future directions for MAR. First is the LiDAR scanner. LiDAR could overcome the limitations of the camera sensor. It could provide a more realistic experience. It's reasonable to believe that the LiDAR scanner would bring significant improvement regarding user experience and interactivity. Second is to study the proper strategy that edge computing could be used to reduce the energy consumption and optimizing placement algorithm. Lastly is MAR and AI. AI could help MAR enhance its key techniques, including building and updating map models, better ways to collect environmental data. MAR and AI could work together to provide innovative solutions to existing constraints. Thanks for listening.